Let's begin. Today's August 6th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 9, 14, 16, 18, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should triangle be greater than 3? Criteria card B looks at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C looks at our 3 digits, triangle, square, and circle, and will let us know which is the absolute smallest among the 3. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card D again looks at our 3-digit solution and will let us know a little bit about the ratio of even to odds in our solution. So should there be more even than odds, or should there be less even than odds? Criteria card E again looks at our 3 digits, triangle, square, and circle, but this time it'll add them up and let us know whether that total sum is an even quantity or an odd quantity. And finally, criteria card F again looks at our 3-digit solution and will let us know a little bit about its structure. Specifically, if there's a pair, as in the example 131, or alternatively, if there is no pair, there are a couple of scenarios. Either all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. Now remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is I want to know a little bit about the ratio of even to odds. So let's go ahead and test criteria card D. Okay, so the Turing Machine does not approve of my proposal. Remember, I do have 314, so that means I've got 2 odds to a single even, but the Turing Machine does not approve of that. So what it's telling me is that, in fact, there should be more even than odds. So let's go type that up in our notes. So we know that even should be greater than odd, and basically we have a couple scenarios. Either we have simply just 2 evens and a single odd, or potentially they all could be even. The next thing I want to test is criteria card E. So again, the way criteria card E works is we're going to add up our digits. So let's go ahead and add up 3 and 1. That gives us 4. 4 plus 4 is 8. So that's an even quantity, but the Turing Machine does not approve of that. So it's telling us that the sum should be an odd quantity. So let's go type that up in section E. And again, that's that triangle plus square plus circle should be an odd quantity. And since it should be an odd quantity, that does inform us a little bit about how the 3-digit solution is going to look like. Remember, we do have a majority of evens, so at a minimum we've got 2. So we know if we add those 2 evens, so far the sum is even. But in order to have an overall sum of odd, that means we need to have that 3rd digit be an odd. So basically what we're looking at is 2 evens and 1 odd. Okay, So yeah, so these two cards in combination kind of already give us a little bit of a head start, so to speak, in how the solution's going to look like. So two evens and an odd. And notice that if we look at criteria card F, we can see, are those evens paired up, or are they all distinct? So let's go ahead and test criteria card F. Okay, so again, notice that in my proposal I have 3, 1, 4 there. I have no pair, but that's incorrect. So that means that the Turing machine is telling me, yeah, there is a pair. So let's go ahead and type that up and say that the solution has a pair, and I'm just going to say of evens, right? Since we do know we have a majority of evens, two evens and an odd, that means that our two evens are equal to each other. Okay, well, surprisingly 3 X's and no crossed out numbers, but that's the way this worked out. And that does conclude our first round. We've already completed those 3 Turing tests. Now we're going into the phase of where we're going to be discussing how to construct a good second round proposal. So notice I didn't test at all the top 3 criteria cards, criteria card A, B, and C. The one in particular that's somewhat interesting is criteria card B, because at this point, since we know we only have a single odd, criteria card B is sort of a 50-50. Either it's there or it's not. Obviously, if it's not, then somehow it's going to have to be 1 or 5. And we do have this minimum between triangle, square, and circle. I think that would be, in fact, that's quite informative, because if we do have a pair of digits, that means that this, whichever is the smallest, has to be odd, right? Because the lone, obviously in a paired up situation, that number is not smaller than itself. So yeah, so very informed opportunity that we know that whichever it is, it's going to be odd, and which means that it can't be 5, right? So we can actually already eliminate the 5s even before we begin. So there's no way the odd can be 5. Way too big for any of the evens. So very interesting how that worked out. And I guess technically we could have done it before we concluded the round 1, but we didn't really discuss that. Okay, so that's very interesting. And so, yeah, now truly it is 50-50. Either it's there or it's not. So that's fantastic. And then, of course, criteria card A looks at our triangle digit and will let us know something about its value. Again, it could be an odd or it could be the even. We don't know. And so I believe, let's see, can we somehow even conclude that there's no 1? Is there any chance of there being ambiguous solutions if we have a 1? If any of them is 1, let's see, if squares say, let's just pretend that it's the smallest. Yeah, triangle will basically tell us what the even might be, right? It could be 2 or 4. Yeah, I think square can be smallest. I think triangle can be the smallest because, again, it's telling us or allowing the triangle to tell us which even it might be. So 1 for square or circle might work. And whichever is the smallest, we know that has to be the odd. So that's interesting. What else can we conclude? So if there is no 3, I don't think, if there is no 3, I don't think triangle could be 1. Because if triangle were 1, then how would you choose your evens for square and circle? There's nothing in here that kind of would tell you what they are. So that's why I'm believing that the smallest, the odd is either going to be square or circle. And again, the triangle is going to tell us which even it is. And then, of course, whichever isn't the smallest among square and circle, the other one's going to be the even. So I think that's how we're going to play it. So let's go ahead, and I'm trying to think of, what would be a better choice, 4 or 2? Typically, you're always deciding between 2 options. So I think I'm going to say there is no 3, which will force the smallest to be a 1, and then what's it going to be between 2 and 4? I'm going to say something like 2, 1, 2. Let's just go with 2, 1, 2. Okay. So let's test. Oh, you know what? Oh well. Just having a little bit of second thoughts. Let's go ahead and test criteria card A to see what the value of triangle is. Okay, yeah. So obviously I chose something that's less than 3. That is incorrect. So so we know we can cross out 1 and 2 in triangle. So it's not 1, or it's not 2. And let's go update our notes and say that A has to be either 3, I'm sorry, not A, but triangle, needs to be either a 3 or greater than 3. The triangle is either equal to or greater than 3. Okay, anything else we can cancel because of it? I don't think so. So let's go ahead and test criteria card C now to see did we get the smallest. Okay, we finally got a check mark. So in fact, C is letting us know again which is the absolute smallest. Square is the absolute smallest. So we know square is also the odd one. So let's go type that up in our notes. So square is the smallest and also odd. So let's go update our notes here. So we know it can't be a 2 or 4. And so we know then, since square is odd, interesting, so triangle is 4. Okay, which means that circle must be 4. As well. So let's cross out everything but the 4. Okay, and so yeah, it comes down to is it a 3? Is there a 3 or not? And yeah, I'm not sure if there's a way to deduce it, because obviously, yeah, both 1 and 3 are less than 4, and that's what I was kind of thinking about, having second thoughts, that not so much this scenario specifically, but that, yeah, that would be the choice. Would it be between 1 and 3 because of the 4 being so large and there being 2 odds? When I chose 2, 1, 2, I think I was thinking of a different choice, and I picked wrong. So, okay, so yeah, let's just go ahead and test if there's a 3 or not, and that's criteria card B. And there is, well, so basically, I was about to say there is a 3, but it's a proving of my proposal that there is no 3. So let's go update our notes in B, that there is no 3 in the solution. Okay, so yeah, so it proves the absence of a 3. So yeah, so let's go ahead and cross out the 3 in square. And so basically that means that the solution is 414. So let's go ahead and type that up. And I guess because of the deduction, let's update the notes in section A that it does not equal 3. So in fact, it's greater than 3, which would be the 4. Okay, and I think everything else looks good. So let's go to verify the solution. Okay, we did say 414, and let's see if it's correct or not. Fantastic, it is. And so now let's go see how we did versus a Turing machine. So I believe we did all 6 tests, and that's a good indication that at a minimum we tied, which would still indicate a win. So the first, let's just say the first 3 were incorrect, and only the last 2 were correct. So we did D, E, F in the first round. So we did D, E, and F, got them all incorrect. We got A incorrect, but we got B and C correct. Okay, how do we do? Okay, so we still beat the Turing machine by 1 question. And, a couple of reasons. I think even though we didn't cross out too many values at the end of round 1, I think the combination of the first 3 cards really just gave us an idea of how the solution was going to look, and then it was just a matter of playing it as efficient as possible. And so yeah, we came up with a solution. So a great solve. So what do you think? If you have any ideas, or would you like to say something, please add them to the comments. If you like the video, please give it a thumbs up so that more people can find the channel. And if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.